Okay, you remind me. All right, so today we are going to be taking the square root of a negative number. That's what we're doing today, square root of a negative number.
Well, you can't do that.
Well, we cannot do that and have a real solution.
So we can have a fake solution.
We can have imaginary solutions. We cannot take the square root of a negative number, and because of that, that limits our manipulation of equations and functions that we could do. So mathematicians created an imaginary number of kind of a placeholder for when we have the square root of a negative number. So what this up here is saying is that the square root of -1 is now equal to lowercase cursive I. Stands for imaginary.
Imagination.
Okay? The square root of -1 is I. So if you turn the page, you'll see some examples. The first one is the square root of -25. We're going to go ahead and make a factor tree. And we're going to break that apart to the square root of 25 multiplied by the square root of -1. Because -1 times 25 is -25. So we break out the -1. And what's the square root of -1?
I.
Lowercase cursive I.
Okay.
What is the square root of 25? 5. So my answer is, and this is the order of writing it, 5I. We're going to treat I like it is a variable, even though it's not a variable. It is a number, it's the square root of -1. But we're going to treat it like it's a variable. So we would normally write 5x, we're going to write 5I. So question B. First thing I want to do is separate the square root of -1 from the square root of 72. And the square root of -1 is I. The square root of 72, that is a perfect square?
No.
No. So if it's not a perfect square, we have to see if it has a perfect square that we can pull out.
6.
What perfect square goes into the 72?
36 goes into 72.
36 multiplied by
2.
2. So we take the square root of 36, and that is 6. And then we're going to write this in the order that you would normally write I if it was a variable. Since it is not under a radical sign, we put it after the 6. And then we always write the radicals last. We write the square root last. So the order you would write that would be 6I square root 2. You do not write it in a different order. That is the order you write it. So as you're doing your assignment, make sure you're looking at your notes. Question C has a -5 out front. And that -5 is next to the radical. And if it's next to, what does it mean? Well, it means multiply. So I've got a -5 multiplied by, now I'm going to break that down. Square root of 9, square root of -1. And square root of 9 is
3.
So now I have -5 multiplied by 3, and then square root of -1 is I. So we have -15I. There are some student examples. I believe 4 of them? Yeah. So take a moment. You try them on your own. Then we'll go over the answers. Oh, man. Oh, so easy to do. So yeah, I forgot to turn on the record button when we were going over the student practice. So I'm going to put the student practice answers up. So if you're watching this video, you can go back and look at like and subscribe. You can go back and look at the student practice and see what the answers were. You can pause the video and look at them. I'm not going to re-talk through all of them. Please pause the video and look at the student practice if you're looking back through the answers. If you don't understand something, come see me, because I accidentally didn't record it. And then after that, we talked about complex numbers. A is the real part, BI is the imaginary part. And we worked out example 2. And I'll work out the student practice so you have that recorded. Finished? So for X and Y for both of them. We never put a negative in our denominator. You're dividing by a negative. Then you have to know a negative divided by a positive is a negative, or a positive divided by a negative is a negative. You don't put a negative in the denominator. All right, I'm going to work out the student practice, so at least that's recorded. Let's make sure I'm recording. All right, it's working. Okay, so we are going to take the real component and set it equal to the real component on the other side. X equals 9. That one's solved, done. And we take the imaginary component and set it equal to the imaginary component on the other side. 3i equals negative yi. And we are trying to isolate y. So I need to divide both sides by negative and I. And by the way, that negative is a number. It's not just negative, it's negative what? It's the same thing as negative 1 if you need that 1 there. So we divide that, and the i's and the negatives cancel. So we get y equals negative 3. Right, the i's cancel there too. Second question, number 6, we have the real component equals the real component. So 9 equals negative 2x. Divide by negative 2. And I leave my answer as fractions because that's going to help us later. Turning into negative 4.5 is not wrong, it's fine. And then we're going to do the imaginary component. So we got 4yi equals 3i. And I'm trying to isolate y, so we divide by 4i. Which cancels the i's. And we get y equals 3/4. Question? Sure. We are treating the I like we would treat X. With respect. Like it's a variable, but it's not, but we're treating it like it is. So when we do this next section, I'm not going to read this for you. This is just a concept that is there if you forget how to do it. And add or subtract the complex numbers, write the answer in standard form. It means we're going to write our answers in A plus BI form. So the first one, we are adding 8 minus I plus 5 plus 4i. You guys know how to add like terms? What is like term with 8?
5.
What is like term with minus I?
4i.
Okay, so you would add your like terms. There is another way of looking at it. You could write it this way if you would like. You write it vertically and then add up and down.
Should it be 12 instead of 13?
No.
7.
You made made me second guess myself. I'm like, what? Because I had 13 in the other class too. Now you should get 13 plus 3i. If you did it by just combining like terms, or if you added them up and down by combining like terms. Next question has a subtraction sign. So in order to combine like terms, you have to get rid of the subtraction sign. Oh, you got to subtract it through the second parenthesis. You have to do that to be able to do this first this question. So we're going to do 7 minus 6i. Then I'm going to subtract 3, and I'm going to subtract negative 6i. What does that do to the negative 6i?
Makes it positive.
Makes it a plus a positive. And we find our like terms. And we've got a 7 minus 3, that's 4. And we have minus 6i plus 6i. Now, I am writing this in standard form. So I put a 0 in for my imaginary part. However, it really does just equal 4. So this would have no imaginary part to it, really. But that is complex form in standard form. The first one is. And then letter C, do you see we have a minus sign out front of the parentheses? That means I have to distribute that minus sign inside the parentheses to get rid of it. So we have 13 minus 2 minus 7i plus 5i. And we look for our like terms. 13 minus 2 is 11. And minus 7i plus 5i is minus 2i. And we leave it like that. Now you actually just skip one tiny little section, but there is a student practice. 8, 9, and 10 are just like these. It's on the second paper. 8, 9, and 10 are just like these. So you're going to take a moment and try those. 8, 9, and 10 from the student practice section.
Just give me example.
Yeah, because we'll do that example tomorrow. Okay, working out the student practice. Since this is an addition, we don't really need it. You have 9 minus I plus negative 6 plus 7i. When you add your like terms, you get 9 minus 6 is 3. And this negative I is, you just take one I away from 7, so we have plus 6i. Treat it just like it was a variable. Number 9 does have a subtraction sign, so we have to get rid of the parentheses first. We have 3 plus 7i minus 8 plus 2i. And then I combine my like terms, I'm going to have a 3 with a minus 8, which is a negative 5. And then I have a plus 7i and a plus 2i, or a plus 9i. And then question 10, we've got 2 subtraction signs with 2 parentheses, so we got to get rid of both of those. So I'll have negative 4 minus 1 minus I minus 5 minus 9i. Then we'll go find our like terms. So I have a negative 4, I have a negative 1, and a negative 5 for negative 10. Then we have a negative I and a negative 9i for negative 10i. And then using what we've learned lately, you could, if you want, write it like negative 10 parentheses 1 minus I. What did I just do? What did I just do for fun? Just for fun. I factored out the,
Negative 10.
which is called the,
Great.
yeah. Oh wait, but I didn't do it right. Now I did. Anyway, I meant to do that. But I'm just showing you, we even have purpose for doing that later. But for today, we'll just get that answer. So your assignment is on big ideas. It says 3.2 day 1. Come see me if you got questions.
I have a question.
Like and subscribe.